Simplifying Rational Expressions, Unit 1, Day 5.
In this video, we will learn simplifying rational expressions through factoring, simplifying rational expressions involving variables, and stating restrictions on the denominators where they equal 0. When we first learned about fractions, we learned about putting them into lowest terms by finding a common factor. For example, if we had 6 over 24, we know that the greatest common factor is 6, so this fraction can be reduced into 1 over 4.
Our second example is 4 over 18. And since the greatest common factor is 2, it can be reduced down to 2 over 9.
Rational expressions have the exact same concept as fractions, except they involve more complicated fractions and involve variables and crossing out like terms. For example, if we had 16x plus 8 over 8x plus 4, we need to try and factor the numerator and denominator to see if we can find any terms to cancel out. So for the numerator, we can see that the greatest common factor is 8. So if we factor that out, we get 2x plus 1. And in the denominator, we can see that the greatest common factor is 4. So when we factor that out, we get 2x plus 1. And then we can cross out 2x plus 1 because they are the same and they're separated by division. So we cross them out, and then we're left with 8 over 4. And 8 over 4 can be reduced even further to 2. So if we were to write this rational expression in lowest terms, we could say that 16x plus 8 over 8x plus 4 is equal to 2.
We need to remember our restrictions, which is when the denominator is equal to 0. We need to isolate for x on the denominator to get our restrictions. So 8x plus 4. And to get x by itself, we move 4 to the other side, which would equal negative 4, and then we divide everything by 8. And since negative 4 over 8 can be reduced, x equals negative 1/2. Therefore, our restrictions is when x can't equal negative 1/2. For our second example, we have x minus 2 times x plus 3 and x minus 7 times x plus 3. Right away we can see that the x plus 3's can cancel out because they're the same, and we're left with x minus 2 over x minus 7 and since that you can't factor anything between 2 and 7, then this question is done.
We have to do our restrictions again, so we have to isolate for x in each of the denominators. So if we have x minus 7 equals 0, and we bring the negative 7 over, we get x equals 7. And then if we have x plus 3 equals 0, when we bring the 3 over, we get x equals negative 3. So our restrictions are negative 3 and 7, and we have to write them in least to greatest, so therefore x cannot be equal to negative 3 and 7.
The first step for solving rational expressions is looking for factors that are common in the numerator and denominator. So for example, we have 2x squared minus 2x over 2x cubed minus 4x squared plus 2x. Two x is common, so we factored that out, and then we're left with 2x x minus 1 over 2x x squared minus 2x plus 1. So in the second step, we cancel out like terms, so we look at the question and we see that the two x's in both the numerator and denominator are the same. Since it's separated by division, we cross them out. And then you're left with x minus 1 over x squared minus 2x plus 1.
So we left off with x minus 1 over x squared minus 2x plus 1. So step 3 says, if possible, factor even further. So we have to check in this question if we can factor the numerator or denominator any further. So we can't factor out the numerator, but we can factor the denominator using 2 different shortcuts. So there's 2 different possible ways to factor the denominator. So the first one is perfect square trinomial, and the second one is finding our special numbers that add to b and to the b value and multiply to the a times c value. So in this case, the b value is -2. So we have to find 2 numbers that add to -2 and multiply to 1, because the a times c value is 1 times 1, which is 1. So we know that our special numbers in this case would be -1. So then we just sub that into the denominator as if we were doing FOIL backwards. So we're left with x minus 1 times x minus 1. So step 4 is to cancel out like terms, if possible again. So we left off with x minus 1 over x minus 1 times x minus 1. So we can see that the x minus 1 and x minus 1 can cancel out because they're like terms and they're separated by division. So then we are left with 1 over x minus 1.
So the last step is to always remember our restrictions. So in this case, we look at the denominator and we see that it's x minus 1, which equals 0. And we put the -1 over on the other side, which equals 1. So then therefore our restrictions is x can't equal 1. So in summary, we need to remember these main 5 steps for simplifying rational expressions. 1 is to look for factors that are common to the numerator and denominator. 2 is to cancel out like terms. 3, if possible, factor even further, for example, using perfect square trinomial. 4 is to cancel out like terms, and 5 is to remember restrictions.
So basically you're just factoring until you can't anymore, and you're crossing out like terms until you can't anymore. And we also need to remember that we cannot cross out like terms if addition or subtraction is separated by division, because addition and subtraction is not the opposite division. So for example, if we had x minus 5 over x minus 3, we cannot cross out the x's to get -5 over -3, because you cannot cross out half of the terms in the bracket, and the x's are also using subtraction, and subtraction is not the opposite division. And that is how you simplify rational expressions.